Okay, so we're continuing with the same scenario, regression analysis on the relationship between the average annual profits in millions of dollars, insurance companies, and the yearly number of major disasters gives the following computer output. Please remember, and again, I just keep stressing this, where you see the word constant, it's either going to say constant or intercept, but regardless, this is your y-intercept. So this is your y-intercept. And this is my slope line. That single word always tells me what my x is, even if I can't distinguish here. But I know that they're saying annual profits versus natural disasters. So because this is my x, this must be my y. Reading it, I would not have known, but here it gives me the hint. The very first thing it asks me to do is write the regression equation. And they will say this like this all the time. And my immediate response is, because this is the way I did it in school a long time ago, but I would go, okay, A, y hat equals, and 420.727 minus 2.70909x. And that's great. The only thing is, if I do that like that, I have to define my x and y. So we're going to define our x and y again. So let y equal the annual profits in millions. I'm going to just keep it short and call it annual profits. And let x equal the number of natural disasters. Now, if I'd wanted to, I could have done it like this. I could have said annual profits equals, and put a big hat on top of that, 420.727 minus 2.70909 times number of disasters. If I had written it like that, I wouldn't have to write this off to the side. But somehow another, you can't just write the equation. Even though they just said write the equation, you must define the variables. So you can either define the variables inside the equation like this, or you can define them off the side and make sure, and this is critically important, that this has a hat and this is a hat. If they don't, they probably will not give you credit for that entire answer. All right. And that's an easy question to get right. I think mainly they're trying to pick on you for whether or not you recognize that you need the hat for the y hat. Write the coefficient of determination and explain its meaning in context. Usually they're going to give you two to mess you up. They're going to give you r squared and r squared adjusted for this class. For College Board, we'll never use the adjusted. So this right here is my r squared value. So I'm going to say r squared equals 0.465. That's my coefficient of determination. All right, and that's what they asked for. All right, so 46.5% of the variation in y, so in annual profits, can be explained by what? Changes in x, which is the number of natural disasters. All right. Next, they're going to ask for the correlation coefficient. So what is R? Well, R is going to be based on the slope of the regression line. So what is the slope of the regression line? Well, it's negative. So we're going to need a negative sign. We're pulling that from the slope right here. So we're going to R equals negative. If it had been positive, I just put a positive. And it's going to be the square root of R squared, which is 0.465, or at least that's what we got above. All right, so R equals negative square root of negative 0.465. So 0.465, take the square root of that, and I get a negative 0.6819. So R equals negative 0.6819. All right, this is less than 75 and greater than 0.4. So we're supposed to define that in context. And the correlation coefficient, so we're going to say there is a moderately strong, and we need to fill in the direction, negative linear relationship between the number of disasters and profits. So basically, all we're saying, as the number of disasters increases, the amount of profit decreases. And the reason we know that is it's a negative relationship. In fact, one of the things they did not ask for, but I'm going to go ahead and take a moment and do, is if they had asked me to define the slope, I'd go, well, my slope is this. So I'm going to go ahead and make a, for slope, which it didn't ask me to do, but I'm still going to talk about it real quickly. Slope in this case, or all cases, is a change in y over the change in x. And they're telling me that it's negative 2.709 over 1, where this is profits and this is disasters. This is a good start in defining slope. That doesn't define slope, but if they ask you what your slope is, you're going to give them you're going to go, okay, negative 2.709 profits over 1 disaster, and you're going to say for the slope is negative 2.709, and for every 1 unit change in every 1 increase in the number of disasters, for every for every 1 change in disasters, or every 1 chain increase, for every 1 unit increase in the number of natural disasters, profit decreases by $2.709 million. So for every single natural disaster that occurs, profit decreases by 2.709, right? And I said 1 unit increase, but you can say for every natural disaster that occurs, profit decreases by 2.709. The next thing says, over here, it says calculate S in the context as a problem, and explain what it means in the context of this problem. Well, first off, a lot of times they're not going to give you that value, or I might not give you that value. So let me tell you where that value comes from, because you're going to need to know that you're looking for this column and the residuals, right? So if you're looking for S, you're dealing with the residuals, and it's like, oh, well, that's good because the S is the standard deviation of the residuals. So 930.327 divided by 9. And so that's where that came from. All right. And then I just need to take the square root of this value. So raised to the half power. So basically, I'm going to go ahead and write this down for S. Actually, I'm going to go ahead and move to a separate sheet of paper because I'm obviously not have enough room. So S equals 930.327 divided by 9. And then we're going to take, and that equals 103.37. Take the square root. And when we do that, we get S equals 10.16. Okay, now this is the one that has kind of a long sentence with it, all right? S equals the standard deviation of residuals. Now that's not going to get you a whole lot of points, but at least lets the reader know that you know that what S stands for, all right? And you calculated it correctly. And so the very S equals the standard deviation of the residuals and equals 10.167. And measures the amount of variation in profits for a given number of X of disasters. All right. Okay, the next thing it asked for. It did not ask me for the standard error of the slope. Please remember, standard error of the slope is this. This is standard error of the slope. And the standard error of the slope, remember, tells you how much variation there is in the slope. That's not what it asked for. The next thing it asked for us to do is to run a test to determine whether or not the slope is significant at alpha equal 0.05. All right. So we're going to run a test to determine whether or not it's at 0.05. We already defined X and Y, but let X equal the number of disasters. Let Y equal the annual profits or the profits. By the way, since we've already done this on the same problem, we don't have to do it again, but I am. All right. My null, HO, beta 1 equals 0. There is no linear relationship between X and Y. HA, beta 1 does not equal 0. There is a linear relationship between x and y. All right. We need to define beta 1. Let beta 1 equal, and the best way to say that, equal the amount of change in profits for a 1 unit increase in the number of disasters. All right. So beta 1 is the amount of change in profits for a 1 unit increase in the number of disasters. The next thing we need to do is conditions, and they're given. Conditions given. We can check that off. All right. After we've done that, we need to write down our equation, which is T equals B over SB. So T equals B over SB. So T equals slope over the standard error. And our slope is negative 2.709. And our SB is 0.9694. So we're going to end up getting a T star, and we've calculated this in a previous video, but this is good practice for you. Not a T star, a T statistic. This is not the T star, this is a T statistic, negative 2.70909 divided by 0.9694 equals negative 2.794. So if I were asking you to fill out the chart right here, you would write negative 2.794. We're going to go ahead and calculate the probability of that. So we want so we're going to look for 2 times the probability that T is less than negative 2.794. And once again, the reason we're doing the 2 is because our alternative hypothesis was a not equal. So here we go. From the calculator, second vars, TCDF, lower bound, there it is, degrees of freedom. Once again, they didn't give us our sample size, but we have our degrees of freedom right here on our residuals. All right. And we end up getting 0.015, but I need to multiply by that 2 times that. And that equals 0.02105. So p-value alpha, this is going to be 0.0210. This is 0.05. This is less than, and we're going to reject the null. And by the way, normally on a computer printout, that p-value would have been given here, and they would have said the p right here, they would have 0.0210. So if we ask you for that value, there it is. All right. So in this particular case, our slope is significant. So how do we go about saying this? Well, we know we now have substantial evidence. So our p-value is 0.0210. We reject the null. There is significant or sufficient, excuse me, evidence at alpha equal 0.05 to suggest that the true population slope is not zero or is different than zero. All right. Then we need to give our simplified, and we always need to give our simplifiedness. And our simplifiedness, I'm going to write in black ink. There is a linear relationship between the number of disasters and profits. So what that tells you is X, or the number of disasters, is a good predictor for profits, right? They didn't ask that, but number of disasters would be a good predictor. If we determine that it's statistically significant, then it is a good predictor. So statistically significant is equivalent to saying good predictor. Please notice this was not statistically significant. We had an alpha, a 0.02 alpha level, but it is at 0.05. So if you change your alpha level, you may or may not, you sometimes will reject when you wouldn't have otherwise. All right, so this concludes this video. Thank you.